All right, so in section 9.8, we're talking about the area of regular polygons. This happens to be the last section in the unit, and then so of course your Unit 9 test will be next time. And so in this section, again, we're revisiting the definition of a polygon. And so a polygon is a two-dimensional closed figure made of segments, right? Now, when a polygon is regular, that means all sides are congruent and all the interior angles are congruent. Now, here's a new word that we're coming to, the apothem. It's the segment from the center of a regular polygon to the midpoint of a side. So like here we've got a polygon. This is a pentagon. Remember, two-dimensional, closed figure made up of segments. And it has 5 segments, 5 sides, so that makes it a pentagon. So the apothem is the segment from the center of the figure all the way to the midpoint of one of the sides. It'll hit it at 90 degrees, and it'll cut that side in half. That's the apothem. And the apothem could go to any side, any one of the 5 sides, or 3 sides, or 4 sides, or 8 sides, whatever polygon you've got there. So that is the length of the apothem right there. Okay, so that brings us a formula for the area of a regular polygon, right? So up to this point, and remember in the last chapter, we had formulas for areas of all kinds of different figures, rectangles, rhombus, trapezoid, all those things, parallelograms. So now this is the formula for area of a regular polygon. Now, the reason why we waited till this unit to include this area formula and didn't put it in with the other units is because you need sine, cosine, and tangent in order to answer these types of questions. So that's why we throw it in at the end of this particular unit, because now we have done the trig functions. So in this formula, of course, A stands for area. P, capital P, is the perimeter, right? Okay, that's going to be the perimeter of the polygon all the way around, all the sides added together. And A is the apothem. Okay, so once you have those two things, you can plug it in and find the area of the regular polygon. So like, for example, in this one, we want to find the area of this regular polygon. All right, so a regular triangle is otherwise known as an equilateral triangle. What have they given me? The apothem here is x, and this side is 20. So, of course, if one side is 20, they're all 20. So what's my equation? So area equals the perimeter, whoops, 1/2. I need to put that in there. Area equals to 1/2 the perimeter times the apothem. All right. So now, when we go and we start plugging these things in, okay, remember P stands for perimeter. We can find that pretty easily. It's just the distance all the way around the figure. 20 times 3 is 60. No problem there. The perimeter is 60. Now the apothem we're going to have to go through and calculate because they don't give it to me. All right, now, okay, here's the first step in doing that. Okay, so in order to calculate the apothem, I need to go ahead and draw in this segment that connects the center to this vertex. Because now I have created a right triangle, right? Here's the next thing. Remember the apothem cuts this side in half? So if the whole thing's 20, then each half is 10. All right? So take a look at what I've created here. Okay, I've created a right triangle where I'm looking for this leg. I have this leg is 10. Okay, the only thing that I need to set this up with tangent, opposite, and adjacent, the only thing that I'm missing in order to set this up with tangent would be this angle, right? Would be this angle. Okay, so if I can come through and figure out what that angle is, then I would be able to set it up with tangent. All right. And so in order to set this thing up with tangent, I need to find this angle. Now, here's the idea. Okay, all the way around is how many degrees? All the way around the circle. So a full circle is 360 degrees, right? The full circle is 360 degrees. All right, so if I draw in a segment to every vertex, that 360 is being divided by 3. All right, that 360 is being divided by 3. So if I go in and I do 360 divided by 3, that means each one of those 3 is 120. So each one of these 3 is 120 degrees. Now the apothem comes in and cuts this 120 in half again, right? So 120 cut in half again is to 60. So that angle is going to be 60 degrees. That angle is going to be 60 degrees. Now you could find this angle as well and use that and you would get the same answer. In this case, it's probably pretty easy to find because you know in an equilateral triangle 60, 60, 60, right? Adds up to 180, and cut in half would be 30. So it would be pretty easy to find that one. However, if it was, say, a pentagon, all right, that wouldn't work because of it'd be a lot more work in order to try to find it, because you'd have to find each interior angle. Remember, there was a formula for finding that, and then cut it in half. Really, 360 divided by number of sides divided by 2 is faster, and then that would work every time. Okay, so our aim will be to try to get this angle. All right, so now I have to go off to the side now and calculate the apothem. Remember, if this is my reference angle, 10 is the opposite, right? And x is the adjacent. Opposite and adjacent, I'll set it up with tangent. Okay, so the tangent of 60 degrees equals to opposite 10 over the adjacent, which is x. Now remember, if you don't remember sine, cosine, and tangent equations, they'll be in that notes for 9-6. Okay, so go back and look those up if you need to. So how do I solve this? I'll multiply both sides times x to get x out of the denominator, and then I'll have x times the tangent of 60 equals to 10. And so if I'm trying to isolate the x, I've got to divide both sides by the tangent of 60. Tangent of 60. And so when that happens, my x is going to be equal to whatever 10 divided by the tangent of 60 is. So let's take a look and see what that's going to be. So I'll go now to my Desmos calculator, and I want 10 divided by the tangent of 60. And before I press enter there, I need to make sure that I am in degrees, which I am. So I get the right answer there of 5.77. So 5.77, that's the length of the apothem. Now listen, we're not done yet, so we can't stop here, because remember, we're trying to find the area of the regular polygon. We just went off to the side here to find the apothem, which goes in for A here. So in order to finish it, I now have to put 577 in for A here, 5.77, and then now I can go in and actually finish the problem by doing 0.5 times 60 times 5.77, which gives me 73.1. And really what I should have done is just left that exact value in there. So let me kind of show you with that. Let's see. I already erased it off. But anyway, if you take it out to the if you take this out to the full number of decimal places, I probably ought to show you that again. So let me go 10 over the tangent of 60. Okay, so that equals to that. Oops. Divide that out. And so if I take that value now and then do it times 60 and then times 0.5. Alright, so then we can see what the actual exact answer is, which is 173.21 is the answer that we'll want there. And then that's one of the choices that you'd be looking at. So it's going to be accurate to 2 decimal places, because remember, when you're doing multiple problems or multiple steps, you only want to round one time, and that's actually at the very end of the problem. Or as you can see, I got 173.1 the first time when I used that rounded value. So you got to be careful with that and make sure you're extending it out to the exact value, because that's the answer choice you'll be looking for right there. Okay? All right. So make sure you get in the exact value. Only round one time, and that's at the very end of the problem. Okay? All right, so what about this one? Once again, I need to find the area. So the area is 1/2 the perimeter times the apothem. And so if I'm trying to figure that out, I can go in and start filling it in. So the perimeter is pretty easy to get. It's 12 on each side, right? And so 12 times 5 would give me 60. So 60 is the correct perimeter there. Times the apothem. So once again, I'm going to have to draw in this right triangle, all right, and see if I can set it up with tangent again to try to find the apothem. Now, once again, don't forget to cut this in half to 6. So I'm looking for this angle again. So once again, all the way around is 360 degrees, right? And so I need to go, let's see, I need to go 360 divided by, how many sides do we have? We got 5 sides. So if I draw a vertex or a segment to every vertex, then that's been cut up into 5 different pieces. So 360 divided by 5. So it's to get this angle, here's the shortcut. 360 divided by number of sides, and then that answer divided by 2. So this angle right inside here is going to be 36. So again, it's always going to be, every time it's going to be 360 divided by number of sides, right? And then that divided by 2. All right? So 36 is what you're going to get there. All right? Now, we can set it up with tangent again. Opposite, 6, adjacent, x. So tangent of 36 equals to 6 over x. All right? The reference angle is 36. The opposite side is 6. The adjacent is x. And like I say, remember, if you don't have the equations or don't remember them, you can look them up in 9-6. Okay? So I need to multiply both sides times x here. Both sides times x here. And so that would give me x times the tangent of 36, and that's equal to 6. Now I'm ready to divide both sides by the tangent of 36. Tangent 36. And my x is equal to, well, let's see what it's going to be equal to. Alright. So I'll go back here. This time I want to change that top number to a 6. I want to change that bottom number to a 36. Alright. And so let's take this off of here for the moment, so that I can see that that's 8.26. 8.26. So that's, remember, your apothem. All of this was to find the apothem, which always goes in for A into this formula. So don't stop here, because this will be probably choice A. So you don't get this and stop and say, there's my answer, because remember, answer the question, you're trying to find the area. So that's times 8.26 here. And so now we can still keep that exact value and do times 0.5 times 60. Alright, so now we've got the full area, which is 247.75. Alright. So remember, if you use the rounded value, then the area that you get would be probably close enough to get it right on a multiple choice, because I don't envision a bunch of answers being right here around this number. Like one will probably be 247.75, the other one will be like 302.86 or whatever. Okay, so if you used a rounded off value and got 247.9, then that would be close enough for you to know which one was the right answer. But if it's fill in the blank and it says be accurate to 2 decimal places, then you better use the exact value and be accurate to 2 decimal places. Okay, so one more example that we want to take a look at here. And so once again, I'm trying to find the area of this thing. Same formula. 1/2 the perimeter times the apothem. Let's go in and start plugging this in. The perimeter. Now, take a look at how this is different. Now, this half a side was given to me as x, right? This half a side was given to me as x. So now, the apothem is not what's missing, okay? It's this value to help me get the perimeter is what's missing. All right, so that's how this one is different from the last one. So how does it work? I'll still set it up with tangent and come up with the value of the x here. So all the way around is 360, and so this is going to be 360 divided by 360 divided by 6 sides this time equals 260. And then so if I do 60 divided by 2, then we've got 30. So 30 goes there. So once again, remember to get this angle, it's always 360 divided by number of sides, and then the apothem cuts that in half again. So 360 divided by 6 is 60, and then 60 cut in half again makes this 30. So that's the rule for getting this angle. 360 divided by number of sides divided by 2. All right? So keep that in mind. That's how you get this angle. Now we're ready for tangent. So we'll go tangent of 30 degrees equals opposite x over adjacent 5 square roots of 3. Okay? So from here, I will just multiply both sides by 5 square roots of 3 because I want x by itself. All right. And so that's just going to be x equals whatever 5 square root of 3 times the tangent of 30 is, and something nice happens here. We'll go 5 square roots of 3 times the tangent of 30 degrees, and notice it comes out to be 5. And so if this is 5, then the whole side is 10, and that makes the perimeter 10 times 6, which is 60. And of course the apothem they already gave us, 5 square roots of 3. All right, one more step to finish it, and we're going to go 0.5 times 60 times 5 square roots of 3, and then so we have our answer. It's 259.81, we'll call it. All right. Okay, so there we go. That's everything that you need to be able to work on and finish now your quiz.